Hi, everyone. In this video, I want to show you how you can take a correlation coefficient in a way that is, in one sense, by hand, but in another sense, uses the aid of Stata to show you that you can exactly reproduce Stata's calculation of the correlation coefficient in a way that exploits the actual formula for correlation rather than just writing something like cor xy like this, but which also spares you the trouble of laborious hand calculations and also shows you that this result matches data exactly, whereas if you compute simply by hand, you're going to have some rounding error, and that is sometimes disruptive to people when they're first learning this because it can seem unsettling. Your answer doesn't actually match what the computer tells you. So let's do that. I'm going to show this not with the homework data, since that would sort of defeat the purpose of homework, but I'm going to show you using some data that I use as an example in class. So we're going to come here to miscellaneous resources, and then we're going to use the commute pay data. You'll have to forgive my dog bouncing around in the background here. So we can download this, and you want to put this in the folder that you use for this class. So for me, you can see that's this here, and I'm going to put it in my data folder. And I've already got it in there, but you can see that that's what you would want to do. So let's come back to Stata, and we're going to put up a do file since you should submit a do file for this homework. And remember that our standard do file should have a date, just like a sheet of paper you would submit, so 2023-02-03. And I think it's a good idea to date your work in this way. Author, my name. And you really don't need a whole lot of other information. You can say task, various checking of hand calculations, homework 2. Something like this. And then you need to set up your standard do file header. So we write capture log close, set more off, clear all. And we could set the version here, but we don't really need to declare the version at this level. And then you'll have various sorts of answers prior to the one I'm going to show you, because this is the final question that we ask for Stata calculation on. So we're going to here just kind of represent that by saying something like question 2.15 is the first, and then you would have some material down here. This would be some actual code. Obviously, don't write that. But then we'll kind of come down and we'll start question 4.10. So this is what it would look like. Now, again, I'm going to use the data for a different data set just so you have something to do on your own. So what I want to show you here is that we can actually get that correlation coefficient roughly by hand. Again, we're going to use Stata to actually do the calculations, but we're still using the raw formula on our own. So we need to actually come up here and change our directory. So let's change the directory to desktop, Soch 360, SP23. You'll need to change this so that it goes somewhere on your computer. And then we need to put together our log file, and we'll just say log using homework. I should just put it in the base folder. So log using homework 2, replace text. Okay, so we can run this and make sure that all this works, and we're in good shape here. So now let's load the data. So we're going to say use, and I've got my data in a special data folder. You can omit this part if you're just using one folder. At this level, you don't really need to have a highly architectonic folder structure. So we'll say use data, and then this is called commute pay. Again, you want to substitute this with the Coral data. And then we've already cleared all, but I usually just write clear for good measure here. It's a good habit to get into. And you can see that because we downloaded the data to this folder and then used it in Stata, it pulls up. So now we want to take the correlation coefficient by hand. And you'll recall from our discussion in class that the correlation coefficient is in many ways very beautiful, and it can be seen from a whole variety of angles. But the angle that I want to show it to you from at this moment, which is really useful in calculating it, is that it is roughly the mean z product of two variables. So what we need to do first to calculate that is to turn each of our variables into a z-score. And let me show you the way that you can do that. So we'll first summarize one of our variables. We'll summarize commute in miles. And you can see that it returns the mean and the standard deviation. And if you look in the command for summarize, the command help file, I mean to say, you'll see that Stata stores these results in these return values here. So for instance, I can write display our mean, and the mean pops right back up. So what we want to do here to calculate a z-score is exploit that fact. You could write it by hand, but this is much more convenient. We want to make a new variable, and we'll write generate z commute. You could also write commute z, it doesn't really matter. You can call it anything you want, but this is probably the clearest. And then we'll just say that that's equal to the standard score. So what's the standard score formula? We have the original variable minus the mean, and then divided by, and we saw before that that was standard deviation. So let's run everything from the top. And we can see here that we have z commute. So let's go ahead and display some summary statistics for that value, and we'll verify that it looks like a z-score. So what should we expect to see here? Sum z. So the mean, you can see this is technically not 0 because of computer limitations on exact calculation, but you know that this refers basically to an extraordinarily small value. It's effectively equal to 0. So what that means is that we have a variable that's got mean 0, which means it's been centered, and it's got a standard deviation of 1, which means it's been standardized. So that's a really good sign. Now let's do the same procedure for what I call the earnings here. So we're going to say sum earnings. And we have to do this because that's the only way to get the return values in Stata's working memory. So if we tried to make another z-score variable by just writing this here, generate z earnings equals earnings minus our mean divided by our SD. Let's try to do that now. I'm actually going to show you that this causes an error. So I did not run sum earnings here. So let's summarize our two z-score variables here. And you can see that z earnings is a mean of 42 and a standard deviation of 21 and change. What's the problem? Well, we pulled the return values from not the earnings variable, but from the commute variable, because those were the ones in memory. So we really have to run this first to access those return values. Now, I did put the code here correctly, but I just didn't run this line. So if I rerun the whole do file, we should be in good shape. And we can summarize again. And now we have this nice outcome that these both have mean 0 and standard deviation of 1. Okay, so what is our next step? Well, what we want to do next is make a vector, or just a variable, basically, that's got the products of these things. And then we'll be able to get from that the sum of that vector, and then, pardon me, its mean as well. And then we'll need to take the rough mean to get the final answer for correlation. But we'll get to that when we get to that. So we're going to make one more new vector, and let's just call this the z product vector or variable. So we'll say gen z product equals z commute times z earnings. And let's go ahead and list that out. So this will just list all the observations. And you can see here that this gives us the z products. And why don't we actually list, we'll just list, I'll show you something cool you can do. So to list every variable that starts with z, which was one reason to write it this way, we can just write list and then z asterisk. And you can see that we get the products here. So this is the product of these two things. Notably, this is an easy way to spot check it. 0 times anything is 0. So we get 0 here. And we can spot check any one of these. So let's spot check the one that's right there. We can just manually do this. So this times this should equal this. Oops, sorry, I need to get a better handle on my trackpad here. And we do get the same thing with rounding. So that's a very good sign. Okay, so now what's our next step? Well, we want to take this z product variable, and we want to write sum z product. Now, the correlation is not exactly equal to the mean of this thing because it's not literally a mean. We have to take 1 out of the denominator, and since we've only got 5 observations, it's actually going to make a relatively large difference here. So how could we do that? There's a variety of ways to do so. One of them would be to write sum z product here, And then when we're done with that, to display the mean that we just got times, and if we have n in the denominator of that mean and we want to swap it out with n minus 1, that means we need to multiply by n over n minus 1. So we can just say, and by the way, Rn is also a return value, so we can say Rn over, and then Rn minus 1. We got to get our parentheses all set up there. And you can see that we get this answer here. Now let's double check and make sure that that does equal the correlation coefficient. So we'll say correlate just the two original variables, commute and earnings. And you can see that that gives, with rounding, the exact answer, which is pretty cool. And we can even get the full list for the correlation coefficient here. So if we come here, you can see that we can actually print the entire thing here. So let's do that. We'll say dir row, or at least print more of it. And you can see that to a very close degree, these match. So they're only off by, farther away. Let's count even here down to the 3. So we're talking about, what, the 100,000ths or millions. I'm not going to count all those out, but they're off by a tiny factor, much closer than the hand calculation comparison. Finally, what's one more approach? So one other thing that you could do would be to sum the z product again, get it into working memory, and then note that there's this interesting fact that you can, if you look at the sum help file, one of the return values is literally sum. So sum in Stata, when it's a command, means summarize. But if you also want the total of the variable, like all the observations added, you can just write rsum. So that allows us to take a pseudo mean by hand. So let's now say display rsum, but over, instead of n, we want n minus 1. So over Rn minus 1. And that, again, gives us the same answer that we saw above here. So that's the way that you could take a correlation coefficient by hand, which is not, it's kind of perched between doing this by hand with a lot of rounding, which will give you answers that are different to Stata. But we also actually use the formula here rather than Stata just telling us how to do it or doing it for us, which I think is instructive at this level. I wouldn't recommend doing this at higher levels because it's a bit of a waste of time. But notice that you can always do this for any given two variables. So if you have GSS data, you could simply, and there's a way to program this where you virtually have to change nothing, you could program a calculator for the correlation coefficient that works just as well as Stata's literal correlate command through your knowledge of the underlying statistics. That's where I'll leave this lecture. Thanks so very much for everyone for watching, and contact us if you have questions.